So following on from the previous video, we've got to identify all the max, min and saddle points for a given surface. So for this given surface. So the first step is to identify where f of x and f of y both simultaneously equal 0. So if you're at the top of the hill, then in the x direction the gradient will be 0, in the y direction the gradient will also be 0. So we've got to identify x, y where it equals 0. Okay, so looking at the surface, take the partial derivative with respect to x. So this would be a variable, constant. So when you differentiate this, it would just be this. Differentiate this with respect to x, that would be 4. And then take the partial derivative with respect to y. So this is a variable, so differentiate this would be -1. So now you've got this and this. You want to identify all the points where both of these are equal to 0 simultaneously. So equals 0, equals 0, equals 0, equals 0. So as it turns out, this point here at x equals a half, if you put this point here, a half, comma 1, then at this point here, both of these would be 0 simultaneously. So we should be looking at this point here. So looking at this point, we know there's something fishy going on at this point here, but we don't know if it's a max, or we don't know if you're at the top of the hill, or if you're at the bottom of the hill, or if you're at the saddle point. We just don't know. We just know that there's something fishy going on because fx equals fx and fy equals 0. We just know that there's something fishy going on. We don't know what it is yet. So let's look at the concavity in the x direction. So look at the concavity. So looking at this, differentiated again, that will then give us this, and then evaluate it at our fishy point. Our fishy point was something fishy going on at a half 1. So evaluate it. Hang on, let me think. Evaluate it at. Hang on, let me think. Evaluate it at half, 1, not 1, half. Hang on. Evaluate it at. Hang on. Evaluate it at half, 1. Okay, so hang on. So putting this into here, that will then give us a quarter. Y, there's no y in this thing here, so ignore the y. So that will then give us -8. So we can see that the concavity is -8. If you're truly at the top of the hill, then the concavity is always downwards. It's always concaving down. So this is pointing in the direction that is concaving down, meaning we're at the top of the hill. But don't forget, it could be a saddle point. So this alone is not sufficient. We've got to perform this thing now. We've got to look at this quantity. If this quantity is greater than 0, then we can conclude that we're at the top of the hill. But we don't know yet. We just suspect that we're at the top of the hill. So to look at this quantity, we would need fxx, which we've already got. It's right here, fxx. We now need to look at fyy, and then later on fxy squared. So let's look at fyy. So looking at fyy, we've got fy right here. So differentiated again with respect to y, that will then give us this thing here. That will then give us this thing here. So now we need to evaluate it at not 1, a half, because that's a mistake. So hang on. Not at 1, half, but at a half, 1. Okay, so we need to evaluate it at a half, 1. So put this. This is the y here. This is x. This is y. So put 1 into the y here. So the whole thing here will be -1. So now we know that this is -1. this we know is -8. So combining the two would be +8. Okay, but we need to look at this quantity here, fxy. So we need fxy. So going back to here, you can either remember fxy is the same as fyx. We've done this before. I'm expecting you to know this. So you can either differentiate this with respect to y, or you can differentiate this with respect to x, because these two are the same. Well, it turns out that if you differentiate this with respect to x, it would be 0, because there's no x in here. Differentiate this with respect to y, it will still be 0, because there's no y in here. So this thing here, is actually 0, and then square it, it will still be 0. So overall, this thing here will be the number 8, and then you take away 0 squared, which means that this whole thing here is the number 8, and this whole thing here, that number 8 is actually bigger than 0. So we can definitely conclude, well, this is satisfied, this is satisfied, so we can, because both of them are satisfied, we can definitely conclude that it's a max. Okay, so if you jump to a 3D graph plotter, punch in your surface, and then at that point, at the point, what was it, a half 1, at this point here, and then if you want to know the height, then put a half and 1 into a function, and then it will jump to the height, whatever it may be. But you can clearly see from the diagram that is a max, which is what we worked out here. It's a max. Okay.